Good afternoon, ladies and gents. We are taking a peek at the Super Quiz preview, getting you ready for our upcoming Super Quiz. I am going to kind of quickly work through some of these, so if I get going a bit quick at times, like I did with my mouth there, you can feel free to pause me, rewind me, do whatever you'd like with me. So, without further ado, here we go. Okay, first couple pairs here. Whoops. Yep, 4 terms we are grouping. Each pair we're looking for the greatest common factor, stressing greatest. Like 140 and 28, don't go easy on me here and say it's 2. You need the biggest number that goes into both, which is 28 in this case. Smallest exponent, and then we just divide out. 40 divided by 28 is 5. M to the third divided by m squared is m. And when you get over here, be careful. You're like, I've got everything. I'll just leave it as 5m. What would you multiply something to get itself back is the question here. 1. Okay. Move to the next one. Biggest common factor. 105 divided by 21, 5. 21 divided by 21, 1. And that's the key. If those are the same, we're golden. So to write my final answer, because don't just leave it like this, take your greatest common factors, take your common set of factors, and normally, 9 times out of 10, you're done at this point. You're like, why aren't we done on this one? Look at your first quantity. They have anything in common. Really, Hardy? Yeah, really. Yeah, I can take a 7 out. Okay, so take the 7 out. Doesn't mess with the second one at all. So this again, if this is a quiz question, you stopped here, you're probably going to get dinged for like a half out of 3. So no worries. Okay, next one. Same idea. Pair them off. You won't always have a number and a variable. Sometimes it'll just be one or the other. Like here, we just got the m squared. So we need the 7. 3 over 2 is 1. Got the m squared. Okay, there's the magic value we're hoping for. So I look over here and I get the 7. Now, if you're not sure about the sign, negative 49 divided by 7 would be negative 7. Well, that's not the same. But if I make that a negative, negative 49 divided by negative 7 is positive 7. 21 divided by negative 7 is negative 3. And they're the same. And this is not one of our 1 in 10 times here. Now, if that would have been 4, would I have needed to break this down more? Yep. 9? Yep. So always be cautious of that first one to see if you need to break it down anymore. Okay, more factoring. Now, 3, use a little common sense here. Take the x out. Just has me lose an x on each of these. And now what's left in the parentheses better be easily factorable at this point. Don't forget that x out front. Don't think you're just dividing it out and it's not there anymore. It's still there. It's still got to be a part of your answer. Now, 4. 4 gets a little interesting at times for people because they're like, well, Hardy, I can see a 5 comes out of all of them. And they divide that out. They're going along. And then all of a sudden this panic develops. And they're like, well, I don't know how to do that. That's x to the 4th. Okay, so here comes the question I'd ask you then. If that were the question instead, what would you do? You're like, well, I can factor that easy. Okay, do it. Well, if it was this, I'd do x plus 8 and 6 gets me to 14. Okay, so what's the difference? X squared is x times x. What times itself is x to the 4th? X squared and x squared. One of those, again, if you've practiced, Telling you, it's there. Same with this last one. These are cubes. You've got to know and recognize those are cubes at this point. 5 cubed. 6u. Notice I didn't put the minus in there. Why? The minus gets taken care of in the form. What form? Okay. When we're doing a difference of squares, this is the form that was spoken about when you watched the lesson that you were supposed to watch, okay? That's A, that's B. That's my first term, that's my second. So I'm just going to basically first minus second, sign tells me, square my first term, change the sign of whatever this is. So if this would have been plus, this would have been minus. Multiply my two terms together. Notice again, I didn't take the negative with. Plus my last term squared, the 6 and the u. There is nothing else to do. There is nothing else to factor. You have to know the form. Now, if, and I'm going to do something strange here. It's going to mess some of you up, but that's okay. I'm going to change this, okay, because I want you to see it with plus on one of them. So you are not seeing things. I did this on purpose. What do I cube to get the first term? What do I cube to get the second? You're like, what if I don't know my cubes? First of all, come on. Second of all, okay, if you need to pull them up in the calculator, let me brighten this up a little. Do you see what I see? If you go to the math function and go to number 4, you can type in any value you want and you can get the cubed root of it. Okay? But really, we need to work on knowing those. Now, what's going to be different this time? Since it's a sum, the only thing that changes are these two signs. Now it's plus minus instead of minus plus. Everything else is the same. First plus second. My first term squared, again, both the 3 and the x, minus the product of my two terms, plus my last term squared. Again, nothing else to do besides the pattern. That's it. Okay? Find the inverse of the function. Remember, f of x is a fancy way of saying y equals. And when we're trying to find the inverse, we switch x and y and solve for y. So switch x and y. Solve for y. Okay, I need to get the division out of there. So once we've got that out of the way, again, solving for y. Get 2 to the other side, again, use an opposite. And then divide by, and I don't care. I don't even care if you leave it this way. You can leave it this way. If you're like, I'm used to seeing things in more of a slope-intercept form, that's fine. These are equivalent. I'll take either because they're both the inverse. Same deal on 8. Isolate the radical, subtract the value over, and then just stop and think for a minute. Okay, if this were a square root, what would you do? You'd square both sides, right? Well, it's a 5th root, so take both sides to the 5th. Now, in order for you to multiply out x minus 1 to the 5th, just kidding, pick yourself up off the floor, I'm joking. You're done. Please do not multiply that out. But please do not also do something silly, like distribute the 5 and tell me it's x to the 5th minus 1. Ooh, I'll make like bad pictures of like stick figures sticking their tongue out and stuff on your quiz if you do that. Just leave it, okay? Once we get y by itself here. Please and thank you. Okay. Lots of stuff rolling on this one. Sketch the graph of the function. Tell the end behavior. Zeros, domain and range. Any minimums or maximums of each. So, good news here. On the quiz itself, because Hardy, I'm going to admit it, I meant in my brain, when I was making copies of this, I meant to write all these things in the bottom to make it a little bit easier if you didn't have to do all the writing that I'm doing right now. But as you can see, yeah, my brain got away from me a little bit. So, before we ever start, okay, or even if we want to start, we can. Okay, I don't need to sketch it right away. I like to see a picture though. Okay, there's my cubic. So, first job, we're going to think about end behavior. And remember, with end behavior, your x's are always going to be the same. One to negative and one to positive, because we're looking at this from left to right. Left to right. So again, just think about the arrows. On the left, it's going down. Negative infinity. On the right, it's going up to positive infinity. And that part's good. Okay? Got to get the infinities. Now, zeros. Interesting that we just had a chat about this in class, dealing with this. You're like, wait a minute. Well, I can try looking at it here or trapping them, but remember the easy way sometimes. Second graph, if you start looking through and you happen to see zeros with your y values, because that's what they are, right? Zeros are x-intercepts. You can look here and go, oh, 0, 0, 3, 0. Okay, those are the ones. Those are what I need. Are we going to get lucky enough that every time it's just going to come out of the chart? No. We'll get into trapping on the next problem here probably. But for now, we're good. Okay. Domain, no brain. Domain, infinite, period. Okay. When it's a cubic, when it's an odd degree, forever up, forever down. Okay, so again, anything that's odd degree-wise, that's your domain and range. X, x to the third, x to the fifth, doesn't matter. It's always going to be those two. Then our mins and maxes. Okay, let's do this. I see a min right there. Let's find this thing. We should be experts at this point. We've done it enough. Okay, left. 1, 2, 3, enter. Right. 1, 2, 3, 4, 5, 6. Okay, so my min is at 2, negative 4. And my max, now, can I basically see where my max is? Yeah. I mean, I'll still try, but... Okay, reminder here. If you see E, don't tell me the max is at 1.03, negative 3.2. I mean, we can see that's not true. Whenever you see E, E is 0. 0, 0 is my max. Okay? So now we just kind of eyeball it here. We get a decent looking sketch, we're good. Next one. Again, hearty apologies for having you have to put this part down. I swear my head was in the right spot. It just didn't get onto the paper here. Okay, so now we kind of know the end behavior, don't we really? I mean, it's a parabola. It's squared. It opens up. We see it's positive. I mean, I'm going to pull the graph here in a minute anyway. So you're like, up, up. Okay. Again, any even degreed polynomial. Up, up, or down, down, depending on if it opens up or down. So that would be good for that. Let's see here. Let's get this one in. Now this is interesting. Zeros. Does that cross the x-axis at all? Nope. None. Yay. Okay. Domain. We've said this before. Domain's the same. Any degree. It's an infinite. My range, though, is not going to be. So here I need to play the min-max game first, but I'm like, Hardy, there's no hills. No maxes. Okay, min, that I can do. Hardy, there's no cursor. Where is it? Check it out. X equals 0, so it's over here. What direction do I need to go to get over there? I need to go left. Here it comes. Whoop, there it is. 1, 2, 3, enter. 1, 2, 3. 1, 2, 3, enter. One more time. So let's see here. Min at -4, 2. -4, 2. Range. Bottom. Y value. To top. Bottom. Bottom. Oh, these things that come together, patterns are so much fun in math. And if you don't agree, just don't tell me. All right, solve using the method of your choosing. Okay, but here's the kicker. Answers must be an exact simplified form. Exact. Exact as in no decimals. You're like, dang it, I can't just trap them on the calculator. You're right. First thing I'd suggest, get all your terms on the x squared side. So we're going to add the x over. Okay. You can attempt to factor this. You could slide and divide. You could guess and check. I always try that first. I'll try it, and then if it doesn't work, I'll go to one of my other methods. So here, I don't have a lot of choices. I mean, 6 and 1, that seems too far apart. So I'm going to try 3 and 2. And I got 2 and I got 1 here. So let's see. If I try 2 and 1, that'd be 6 and 2. That doesn't get me to 1. I do 2 and 1, 4 and 3. Oh, I can get to 1 with 4 and 3. Okay. Negative and positive. Like I said, slide and divide would work here. The quadratic formula would work here. Trapping on your calculator, not so much, because that's not going to be exact. So if I do it this way, I set each of my quantities equal to 0 because it says solve. Get my 2 solutions. Okay. Are they both going to be factorable, Hardy? Let's see. Add the 6. Add the 3. Now, if I tried to factor this one, all the signs are plus. Uh-oh. 3 is 3 times 1. Does 3 times 1, or does 3 plus 1 get me to 6? No. Quadratic formula, here we come. Whoop, whoop. A equals 1, B equals 6, C equals 3. So the opposite of B, plus or minus, square root of B squared minus 4AC all over 2A. And as we mentioned before, with being exact with our answers, if you are going to deal with the calculator for anything with this, you're just putting in that value under the radical. Don't put the radical in your calculator. So let's see, 36 minus 12, 24. If the radical you have left over breaks down, pretty good chance it's gonna. Break your radical down. And before you circle, check those 3 values outside the radical. If something goes into all 3 of them, you can put the over 1 if you want to, but you don't need to. That would be okay. Okay? So basically, those are your 2 best options for solve using the method of your choosing. Besides like using an app or something, that is not a method of your choosing that is legal. Okay. Home stretch. Divide. Okay. You're dividing by a binomial. So reminder, if it's a binomial, if it's not just f of something, switch the sign. Watch for holes. 3, 2, 1 constant. Don't lose that 0. First term comes down. Multiply by what's in the box. Comes down. Multiply what's in the box. Comes down. Multiply what's in the box. Do not freak out if it's not 0. We're not looking to see if these are factors. You can get a remainder. That's okay. Started as a cubic. I don't mind if you leave it that way, but normally if stuff is 0, we don't include it. So that's more the route I would prefer you to go. Okay. I'm going to skip over 14. The key is up with that. I'm just trying to save a little bit of time here, and there's going to be nothing special about 14 versus 13. So you can put that back in. Now 15. 15, you have a choice. Some of you had emailed me about this before. You can just leave this as 5x minus 2 and do long division. Or, if you wanted to do synthetic division, you could, but you'd have to go through and divide every term by 5, which is going to give you fractions to deal with. I'm not a huge fan of fractions, so I'm probably not going to do that. I'm just going to go ahead and do some long division here. So, how's this work again, Hardy? Okay, we're going to do some side work here. We take our first term divided by our first term. So first term under the division divided by first term on the outside. Whatever we get, first thing on here. Then we take that answer, multiply it times our divisor, and whatever we get, whatever we get, once we get it right, just like with long division, goes underneath here. The first terms should always cancel. If they don't, something went wrong. So negative 65 minus negative 20 would make it plus. Pull the rest of my terms down. And now we start the process over again. First term divided by first term. Whatever I divide it by, that goes over here. And again, you're subtracting this. First terms cancel. 13 minus 18 is negative 5x. You're like, Hardy, how much longer do I have to keep doing this? Well, in looking, looks like one more time, because I can still divide that by that. Almost there. And if I have a remainder, we just put the remainder in there. Okay. So after all that length that we did during that problem, okay, let's ease up things a little bit here. Evaluate the function of the given value. Plug in that negative 2 every place you see an x. Do not plug in negative 2 over here and then divide by 2, okay? Literally, And again, I don't care if you use the calculator for this whole thing, to be perfectly honest. Uh-oh. 4, 16. See, I even got to slow down sometimes. So negative 8 plus 16 is 8. Minus 10 is negative 2. Plus 7 is 5. Ready to roll. Find all your roots. Hey, here's the recent stuff that we did. One root's been given. So that'd be like if we were looking on the calculator. Okay? So take that value. Do not switch it like we did up in like 13. Take that value. Make sure there's no holes. First term down. Multiply and add. Multiply and add. Multiply and add. Now these, if you've had a root that's been given, you need to get 0 for your remainder. If you didn't, that's a problem. But we did, so it's not a problem. Start 1 degree less, and we now have a quadratic. Now, when I go to solve this, I may be able to factor. Okay? If I cannot factor, I need to go to the quadratic formula. We're doing exact answers again. So, I think about factoring for a minute. I'm like, nope. 5's going to be 5 and 1. I can't get to 2. All right, quadratic formula. Here we come again. A, B, C. Opposite of B. Plus or minus the square root of B squared minus 4AC all over 2A. All right, let's see what we get. 4 minus 20. Ooh, this is fun. 4 minus 20. Negative 16. Ooh. I get to bust out my prop. 2 plus or minus. Pull an I out. Negative. So, square root of negative 16 equals I square root of 16. 4I. Because square root of 16 is 4. Still reduces. Don't stop. And we're good. Got to do what we got to do. Because again, how many roots? 3. 1, 2, 3. We're good. Okay? So one more time, at least on setup here. I'm just looking at one thing quickly as I go. Okay. I want to make sure we get all this stuff in a timely manner. I don't want to put anybody out here. You know what, though? I'm going to go past 18, because again, you know it's factored this. I don't need to keep doing this right now. You've got an answer key. What is wrong with me? Okay. Graph the following function. Then find its inverse and graph the inverse. Okay. So, negative 3x minus 1. Okay, so that's my initial line. So, 1, 2, 3, 1. Okay, so there's my initial line. Now, I even can take it in this form. Either one will work. Switch x and y. Solve for y. Add the 1 over. Divide everything by negative 3. And this time, since I'm graphing it, I'm going to put it in slope-intercept form. Ew. Okay, there's my inverse. Yuck. So negative 1/3, just a little ways down here. We go down 1 and over 3. 1 and over 3. And how I can know I'm on the right track, because again, remember, our reflection is over the line, y equals x, so I can see how those reflect, those reflect, those reflect, and then here I just got a little bit off as I was going, otherwise I'd see that direct reflection there as well. Okay? So the quiz itself tomorrow is going to be 20 questions, okay? I stuck one extra in on this stuff. I didn't stick in some other random thing. But hopefully between this and the key and asking some questions in class, this will be a real good one to finish off the semester for us. So if you have questions, let me know.